Good afternoon. Thank you very much for welcoming us, for welcoming Google to this fantastic gathering. We have new initiatives we'd like to share with you that would be in support of environmental monitoring, global environmental monitoring, which leverage Google's unique strengths. And by the way, thank you, Mark, for that kind introduction. So I was trying to think about where to start, and it seems best to start with the foundation of what Google does today that actually supports environmental advocacy and monitoring, and that is Google Earth and Google Maps. Google Maps is the most popular online web mapping tool today. It's available in more than 40 languages. It covers more than 90% of the world's population. Google Earth just reached 1 billion downloads and also is in all of these languages. So these have brought, I think it's fair to say, a new era of geoliteracy, not just among intellectuals, but actually among some of the very poorest people on Earth are using Google Earth and Maps for example, securing their land rights. There have been a number of environmental victories already with these tools, even though they are just for visualization. And as was mentioned in the introduction, one of the earliest ones was in 2005 when I personally used Google Earth to stop the logging of 1,000 acres of redwoods in my Santa Cruz Mountains community. The information that had been presented to the public was very poor, and Google Earth enabled me to educate policymakers, the media, and my community about what was really at stake with the 3D high-resolution imagery and compelling ability to annotate the map. So that is what led me to found Google Earth Outreach. And by the way, there's a site that we launched, go back one here, to support or to commemorate this reaching 1 billion downloads of Google Earth. It's called One World, Many Stories. I encourage you to check it out. But still, it's only visualization. And when we were in the Amazon in 2008, actually working with Chief Almir, we engaged with scientists there who pointed out that in Google Earth today, you can see the advancement of deforestation over time. You can see some of the dramatic changes that are happening in the Earth based upon the historical catalog of Landsat imagery that we have. But you can't analyze this data. You can't do science. You can't do environmental analysis. And they asked us if we would help them stop the loss of more than 1 million acres a year of rainforest in the Amazon due to largely illegal activities that can be successfully monitored using remote sensing data, using satellite imagery. But the scale of the data and the scale of the processing was beyond the abilities of these scientists. And they said, we know, Google, you have this data. You publish it for looking at in Google Earth. Would you let us have access to it for science? And so that was intriguing, that request. And we brought it back to headquarters and we began to study the problem and educate ourselves on environmental monitoring. In particular, we started with forest monitoring. And as many of you know, tropical deforestation accounts for a significant proportion of greenhouse gas emissions. It is strongly tied to climate change. There's a potential for global poverty alleviation through some of these payments for ecosystem services mechanisms, such as RED, if a scheme for monitoring, reporting, and verification could be widely available. And we saw it as a Google scale problem because it's petabytes of data. Most of you probably know what that is, but many people don't. We're talking about billions of megabytes of data. And the kinds of science that are done on this data are intrinsically parallelizable. And I'll say a little bit more about what I mean by that in a few minutes. But in that sense, computing in the cloud can be a natural solution for environmental analysis at large scale. And as I said, many requests came to us that we could not refuse. So there's 3 tools I'm going to go through kind of blitz through today. One is Google Earth Engine, which is our new platform for environmental analysis. The second is Google Earth Builder, which allows enterprises to upload, store, manage, map, and publish their own data. And then Google Android smartphones with Open Data Kit, which has been empowering local communities all over the world to collect their own data on the ground and participate in the mapping and monitoring. So starting with Google Earth Engine, what are some of the challenges? I think these are probably very familiar to you, but for example, Minister of the Environment of an African nation said to me, Rebecca, our computers are 12 years old. How are we going to possibly manage all the data and the analysis that we're supposed to do in order to participate in these new monetization methods for protecting the environment? So first there's managing this data, petabytes of data from many satellites all over of many resolutions and so on. Then there's the methods, the scientific analysis. These are being advanced rapidly, but how do you get access to these? And then finally, let's suppose you've managed to get the data you need. You've managed to find some application that does the kind of analysis you want. You try to run it, and it takes hours, days, weeks. So we looked at this, and we started this actually as a Google.org philanthropic initiative. Given Google's mission to organize the world's data, world's information, and make it universally available, how could we help here? Well, the natural way to help here is manage this information, make this data that's so large and cumbersome more easily available. Help scientists and governments easily scale up their processing, gain in the speed of analysis, which can be so vital when you're trying to do, for example, law enforcement. There's fantastic science that's locked in these laboratories at universities and so on. Getting it out of those laboratories and into the hands of the people who need it most seemed like a worthy cause. And then once you have this kind of system, you can support transparency, collaboration, and so on much more easily. So we worked on this for 2 years with some of the leading scientists, and at COP16 in Cancun, we announced Google Earth Engine. I think of Google Earth Engine as having basically 3 parts: a data catalog, and then access to thousands of computers in Google's data centers for doing environmental analysis, and then all of the applications that are being developed now on that platform. So looking at the data, this is a slide courtesy of the group on Earth observation. There's a lot of satellites, as I mentioned. There's a lot of data coming in, and unfortunately, a lot of that data, when it comes in, it goes straight onto tape. This is just a visualization of, for example, the Landsat satellite alone, which is the longest continuous mission of Earth observation. It turns out there are in many places hundreds of images of that spot from space over the last 25 years. But again, it has been mostly on tape and has never been used. So our first initiative with Earth Engine was to work closely with the US Geological Survey and systematically bring off tape the last 25 years of satellite imagery of the Earth. We started first with the tropics because of the tropical forest initiatives around REDD, but now we've almost completely finished the planet. We have 1.4 million Landsat scenes, and every month we're getting 60,000 more. And every day we're also getting the new imagery that's being collected. There's a number of other imagery feeds that we're getting, such as MODIS. These are driven by our science partners. What imagery do they need? And then we add those into the platform. Now, one of the things that have frustrated some of you in the past is it's been like pulling teeth to figure out the metadata associated with, for example, imagery in Google Earth. When was that image taken? Well, we have a completely different attitude with Earth Engine. Because this is a platform for science and policy, you must have systematic, authoritative metadata associated with every data set in the catalog. And this is one example of one that we just published a couple of days ago, digital globe sub-meter data, sampled at 180 spots around the planet, which cover the 21 land cover strata identified by Goffsey Gold. This is going to be actually used to systematically validate different land cover maps. All right, computation. So I mentioned parallel processing. What does that really look like? Well, imagine, and you can imagine this is all of a country or all of a continent. Anyway, it's a set of imagery that you want to analyze. We take that and we split that up into pieces. We farm those pieces out to different computers in our data center, and each one runs the analysis on its geographic piece, and then under the covers of Earth Engine, we stitch that all back together into the final result. In this case, this is class light deforestation analysis. Because we do that parallel analysis, we can do in seconds what might otherwise take hours, days, or weeks. I'll give some examples of that. Okay, this is now where it gets fun. You've heard of, well, let me first go through the partners. We're working with a number of leading scientists. We've started with forest and land cover land use change, but we're already also beginning to work with those in disaster response, water resource modeling, and so on. But this gives you an idea of some of the partners. We're working with governments, leading scientists, institutions like Offsea Gold, to bring their algorithms, again, out of their laboratory and into operational use. If you want to see examples of some of those, go to the earthengine.google.org, go to the map gallery, and you'll see some sample products from some of those partners. Now, I mentioned these applications. So iPhone apps, you've heard of iPhone apps, Android apps. Well, the vision here is Earth Engine apps. That is, it's not going to be Google writing all these methods, writing all these applications, deciding what constitutes forest versus non-forest. That's not appropriate. We don't have the expertise. The idea instead is we put this platform in the hands of the world with all the data, with all the processing capability, and make it trivial to bring those methods onto the platform and run them at global scale. So there's already a set of Earth Engine apps that are in development and rolling out into operational use. One is Amazon Deforestation Alerting System with Amazon. We just did a workshop for 40 NGOs around the Amazon basin on this. Class Light from the Carnegie Institution for Science. This does annual deforestation and degradation assessment. We're working with the Natural Capital Project, which is Stanford and WWF. They have a set of models for valuing ecosystem services. The first four that we're moving over are carbon storage and sequestration, water yield, agriculture, and water quality. And again, why are they doing this? They already have an implementation of this on a desktop system. But the problem is it's very difficult for their users to use the system because every user has to get the data, download it, organize computers to run the processing, and it makes it very onerous. We've developed one ourselves called Classification in the Cloud, which is a supervised classifier that lets you upload your own training data for your own land cover classes using raster data or vector data and run Google's machine learning algorithms to rapidly classify those images. So this is an example of, for example, if you just put some points down of two different land cover classes and a polygon, it's that easy, and then you run the classifier and it can run, again, in seconds and classify this imagery. This is a photo of one of my friends from the government of Mexico, Jose Carlos Fernandez, who is the lead RED negotiator for Mexico. We just delivered the Classification in the Cloud Earth Engine application to them, and they're now testing that. He's running it on his iPad. So one example map product that I think begins to show the power of the Earth Engine platform was the finest scale map of Mexico's forest ever produced. We did this in collaboration with scientist Matt Hansen. It required analyzing 53,000 Landsat scenes, the last 25 years of Landsat. It was 15,000 hours of computation, but because we ran it on 1,000 computers in parallel, we got the result in less than a day. And otherwise, it would have taken almost 3 years. We also announced that we're donating 20 million CPU hours of Earth Engine processing, which is enough to do the world many times over, to developing world countries, scientists, and civil society. All right, flipping to, that's Earth Engine. Earth Builder, a few short messages on this. Earth Builder allows you, so Earth Engine is analysis and a large public data catalog. Earth Builder allows you as an institution to upload your own spatial data, cartographically style that data, publish maps easily to Google Earth and to Google Maps. You can, as I mentioned, you can dynamically style it. It leverages the power of Google's infrastructure that we built for publishing Google Earth and Maps, and we bring that to the enterprise so that you have the same advantage of high performance. You can overlay your own content onto ours. This is an example of a project being done right now. These are the first maps produced using Google Earth Builder by WWF. I thought this was appropriate for Eye on Earth Summit. This is their Eyes on the Forest campaign in Sumatra, revealing what's gone on with change due to oil palm plantation and so on in the area. We have, if you want to play with this, we have it at the Google booth, and you can see the different layers and the behind the scenes of how it was built using Google Earth Builder. All right, the last tool is Google Android smartphones. As you know, mobile phones are ubiquitous in the developing world. It's turned out to be a very good way to engage local communities in mapping, monitoring, protecting their own landscape. So we've done trainings in Tanzania, in Colombia, many trainings, and as a result of this and the success of these early pilot projects, we've now formed a group focused on community forest monitoring to share best practices. If you're interested, go to cfm.earthoutreach.org. These are some of the partners in that. These are some of the projects going on right now. You know, interestingly, in Colombia, it's involving former FARC rebels in giving them an alternative activity to do. The one I want to focus on that we're going to end with is the Surui Forest Carbon Project with my friend Chief Almir in the lead. We'll cut to that in a moment. Before we do, I just want to summarize. I might have confused you about Google Earth Engine, Google Earth Builder. They're very complementary platforms, and the synergy between them has not gone unnoticed by Google. So there will be further developments in the coming days on that. But just to summarize, we've taken very seriously at Google that given the scale of our capabilities, we have an obligation to help the planet. And we're not the scientists, we're not the governments, we're not the people on the ground. But what we do have to offer is an unprecedented amount of compute power and the ability to do an unprecedented amount of storage and manage all that for you so that you can then much more effectively monitor the environment. I will end then with our video on the Surui Carbon Project and the collaboration with Chief Almir. Many people are familiar with Google Earth, and environmental groups are using it today to take people all around the world virtually to places on the planet that are under threat. The Surui tribe is also using Google Earth as a tool based on the training the Google Earth Outreach team did in 2008 when we went down to the Surui territory in the Amazon. We taught them how to put their cultural map information on Google Earth and share their culture with the world. However, now the Surui want to go beyond this, and that's where Google Earth Engine comes in.
Para nossa visão indígena, floresta é uma das papel que pode trazer a clima normal. Estamos trabalhando com o projeto Carbono Surui, né? Então, oferecer ao mercado o serviço que a floresta tem para diminuir o gás de estufa.
What you need for what Chief Almir wants is a living, breathing, daily update of the planet. Google Earth was not designed for that. That's what we're building with Google Earth Engine. With Google Earth Engine, we, Google, are focusing on what we do best, which is organizing this information and making it available in a way that's never been possible before because of the scale of the data and the scale of the computational resources required.
The Surui Red Carbon project is one of the most advanced, or is the most advanced in the Amazon today. We're inserting Android handheld devices or telephones into the data collection process for carbon measurement. Because if you're saying you're going to reduce deforestation and in that way reduce carbon emissions into the atmosphere, you need to be able to measure or show how much carbon you're really preventing from going into the atmosphere.
Para medir uma árvore, você tem que tamanho de árvore que está sendo calculado, o carbono lá, né? Então, você vai seguindo o formulário que está dentro do equipamento.
This is the first project really where the Indians themselves are the ones measuring the carbon and being taught how to do it, and they're using this technology. And so the technology allows them to become the carbon monitors.
Você pode usar também para denúncias, né? Se você analisar uma ameaça à floresta, né? Você pode também denunciar isso.
Today, if you want to monitor deforestation in the Amazon, it takes weeks to run the analysis. By the time you've done that, the illegal activities are long gone. With Google Earth Engine, you can build a real-time alerting system based on images that are taken that show what the state of the forest was last week, what is it this week. When you see a suspicious change, Chief Almir and the Surui will be notified. They will go on the ground with the Google Android smartphones and investigate. They will take photographs and videos. They will document what's happening and who's doing it. That will then get uploaded back into Earth Engine for anyone around the world to see the reality of what's happened and then begin to support a law enforcement proceeding.
Como tecnologia, como equipamento Google pode ser importante para construir um futuro melhor, um futuro que tenha consciência. Como é que as pessoas estão construindo solução para aqueles, mas isoladamente, mas precisamos juntar, né? Precisamos pensar em um mundo como fosse nosso de todo mundo, que é, né?
And what's important now is to use the power of the internet to bring together all the voices that can participate in a dialogue toward constructive solutions for the planet. That's what we're building with Earth Engine, and we're putting it in the hands of the world. It's going to be a great adventure. Thank you very much.